All right, guys, let's look at example 6. Now on example 6, we're going to write a paragraph proof and a 2-column proof, and we're going to prove the vertical angles congruence theorem. We will primarily be doing 2-column proofs in this class, but because our book does talk about paragraph proofs, I wanted to do at least one just so you can see and compare the two. Now, I know we just learned that vertical angles are congruent, so some of you may be thinking, why are we having to prove this? Well, remember, a theorem a theorem can be proven. So we're basically going through the proof that shows that vertical angles are congruent. All right, so let's do the paragraph proof first. So we're given that angle 5 and angle 7 are vertical angles, and as we can see in this diagram, we know they're vertical angles because they're formed by intersecting lines. So angle 5 and angle 7 are vertical angles formed by intersecting lines. As shown in the diagram, angle 5 and angle 6 are a what kind of pair? They are a linear pair. Remember, two angles side by side that make a line? And likewise, angle 6 and angle 7 are also a linear pair. Then, by the linear pair postulate, angle 5 and angle 7 are also supplementary. Remember, linear pairs are supplementary. And angle 6 and angle 7 are also supplementary. So, by the congruence supplements theorem, angle 5 is congruent to angle 7. So that would be what a paragraph proof looks like. All right, let's write this paragraph proof as a 2-column proof like we normally would. Let me scroll down just a little bit. All right, so we are given that angle 5 and angle 7 are vertical angles. I'm going to abbreviate big time, guys. They're vertical angles, and that is what is given. All right. Now, I'm going to look at this diagram and I can say, okay, well, angle 5 and angle 6, I'm going to put a comma because there's two pairs, and angle 6 and angle 7 are a linear pair. And over here we can put, we know that because we know the definition of linear pair. Guys, if you know what a linear pair is, you can look at a diagram to see that two angles form a linear pair. All right, well, because they're linear pairs, that means that angle 5 and angle 6 are supplementary. And also, angle 6 and angle 7 are supplementary. And both of these is by the linear pair postulate. Remember, linear pair postulate tells us that all linear pairs are supplementary. And now we can see, here's an angle 6 and here's an angle 6. So both angle 5 and angle 7 are supplementary with angle 6. So by the congruence supplements theorem, that means that angle 5 has to be congruent to angle 7. Remember, congruent supplements theorem tell you if two angles are supplementary to the same angle, then they have to be congruent, and that's what we just used right here. So if you look at the paragraph proof and the T-chart proof or the 2-column proof, you can see that it has the same information in it for the most part. It's just written differently. All right, let's take a break a minute from proofs. I know you guys' brains probably feel like they're about to explode. Just know that's normal. And let's do a couple just basic math problems. So example 7 says find the value of x. Well, we have an x here. Okay. Well, we know this angle here is 3x plus 1, and we know this angle here is 48. And as we learned, vertical angles are congruent, and these two angles are vertical angles. So if they're congruent, that means they have to be equal in measure. So we can say 3x plus 1 equals 148. And now we've taken a geometry problem and we've turned it into an algebra problem. So subtract 1 on both sides, 3x equals 147, divide both sides by 3, and I get x equals 49. All right. On the second one down here, and guys, A, B, and C are all totally separate scenarios. Okay, so do A, forget about it. Do B, forget about it. Do C, and forget about it. So A says the measure of angle 1 is 117 degrees. Okay, so this here is 117 degrees. Okay, now we have to find the measure of the other 3 angles. So we want to find the measure of angle 2, angle 3, and angle 4. Well, we know that vertical angles are congruent. So 1 and 3 are vertical, so that means that angle 3 has to be 117 degrees. All right, now angle 2, let's look at this. Okay, notice that we have a line right here, and angle 1 and angle 2 together form that line. So we can say that angle 1 plus angle 2 are a linear pair, which means they're supplementary, which means they add up to 180. Well, if angle 1 is 117 degrees, that means angle 2 has to be 180 minus 117, which is, what, 63? 63 degrees. All right, so angle 2 is 63 degrees, and then 2 and 4 are vertical, which means angle 4 is 63 degrees as well, which is really cool. When you have one vertical angle, you can determine all of the 4 angles formed by the 2 intersecting lines. All right, let's take the eraser and undo all this. All right, now I want you to try to do B and C on your own, and then I will go over the answers. All right, here's what I got for B and C. So on B, 2 and 4 are vertical angles, so both 2 and 4 equal 59 degrees. And then 180 minus 59 is 121, so I have angle 1 and 3 is 121 degrees. On part C, once again, 2 and 4 are vertical, so they're the same, so 2 and 4 are both 88 degrees. And the others are supplementary with 88, so 180 minus 88 is 92, so 1 and 3 are 92 degrees. All right, we're going to do a couple more proofs, but I want you to really try to stop and do these on your own. If you don't get through them, that's fine, but I want you to try. So I'm going to pause this, I want you to try it, and then we'll come back and go over it. All right, so in this proof, we're given that angle 1 is congruent to angle 4, so I've already written it. Now, anytime that happens, make sure you mark your diagram too. So like 1 and 4 are congruent. All right. Now, if I look at this diagram, I know 3 and 4 are vertical angles. So angle 3 and angle 4 are vertical angles. And I know that 1 and 2 are also vertical angles. So angle 1 and angle 2 are vertical angles. And guys, I know they're vertical angles because I know what a vertical angle is. So definition of vertical angles. Okay, well, if they're vertical angles, we just learned that vertical angles are congruent. So angle 3 has to be congruent to angle 4, and angle 1 has to be congruent to angle 2 by the vertical angle congruence theorem. All right, so let's look at this one right here. It says angle 1 is congruent to angle 2, but I want it to say angle 1 is congruent to angle 4. Well, angle 3 is congruent to angle 4. Oh, I see. Okay, let's go back. Let's look at this a different way. All right, rather than looking at that, we're going to be adding a few steps. Let's look at this and this. Okay, notice that angle 1 is congruent to angle 4, and angle 3 is also congruent to angle 4. So because of that, we know that angle 1 has to be congruent to angle 3, right? That's the transitive property of equality. So if two things are equal to the same thing, they are equal to each other. Now, if I look at these two here, I'm going to rewrite this using substitution. Okay, so angle 1 is congruent to angle 3, but angle 1 is also congruent to angle 2. So I'm going to substitute this angle 2 in for angle 1. I can do that since these are the same. So I could do angle 2 is congruent to angle 3 by the substitution property of congruence. We're using a congruent sign, not an equality sign. And this is the final result that I wanted. Now, there are several ways you could have done this. Some are longer, some are shorter. So if you got something different, but you covered all your bases, don't worry about it. But this is just one of the many ways you can do this. All right, let's do one last one. This is example 9. This will be the final one. So we always have to start with the given. Angle 1 is a right angle, that's given. Well, as we all should know, that if something is a right angle, that means that it is equal to 90 degrees. That's just definition of a right angle. All right, now if we look at this diagram, I can see that angle 1 and angle 2 are a linear pair. And the reason I know that is because I know the definition of a linear pair. Okay, so 1 and 2 are a linear pair. I know that because the definition of a linear pair says so. And then the linear pair postulate, I'm going to go ahead and write that down. Tells us that if two angles form a linear pair, then they are supplementary. So I can say angle 1 plus angle 2 equals 180. Okay, two angles that are supplementary, or two angles that are a linear pair are supplementary. If they're supplementary, they equal 180. All right, well, now I can look back up to here. I know that angle 1 is 90 degrees, so I can substitute 90 in for angle 1. Substitution. Property of equality. And guys, now I can do algebra. Minus 90 from both sides. That's the subtraction. Property of equality. And then if I simplify, I get angle 2 equals 90. Okay, I'm almost done, but not quite. Notice I want to prove that angle 2 is a right angle, not that angle 2 is 90 degrees. But we all know that right angles are 90 degrees. So I can in turn change this to say angle 2 is a right angle. And that's just by definition of right angle. All right, that is all the instruction for chapter 2. Now, over the next several days, we're going to do a ton of example proofs in our proof packet. So if you're still like on the fence, like I don't like this, know that that's normal. Know we're going to do lots of practice, and that we will continue throughout the year. So you'll get lots and lots of practice and you will get better at these.